So we have discussed what? We have discussed that why gx is also a random variable by this diagram. We have discussed about gx, what type of random variability is it? Is a Bernoulli random variable. We have observed that gx is a random variable. Gx is 1 with probability this. P is equal to 3 by 2 e to the power minus 1, right? And 0 with probability 1 minus p, which you can find easily. Now this is what? Therefore gx follows Bernoulli random variable with probability p is equal to 3 by 2 e to the power minus 1.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
Let's do this. It's a very simple problem though, but it has a very enhanced effect and rather idea involved in this problem. So let's discuss that very in depth. So x is a random variable having the Poisson distribution with mean 1. So g is a function from normal 0 comma the union 0 to r, right? Now as you can understand, x is a random variable, so it takes from certain sample space to actually this normal 0 comma in no, not normal, natural numbers union 0. It actually takes values in this. X is a random variable, right? So I'm also helping you revise concepts out there. So x is a random variable. If x is a random variable, it is a function from the sample space to new natural numbers union 0, right? And so understand this: natural number union 0, and then there is a real number. So from sigma to natural number union 0, x is a function, right? And from natural number union 0 to r, g is another function. So therefore, g of x is nothing but a function from sample space to real number. It's also a random variable. So g of x, what I mean, is a function from sample space to real number. So x is a function that is taking sample space values to natural number values, union 0 valuuse. Gx is a function which is taking natural number union values to real number values. So therefore, all over, if you take this whole step, essentially g of x is nothing but taking values in the sample space to real numbers. Okay, so this is very important, this understanding of the idea that why function of a random variable is also a random variable. This is what I explained, because g of x is also a function from sample space to real numbers, so it's a real random variable. Okay, so this is something you should understand. First concept is also a random variable. So now let's see that what g of x explains, what g of x demands from you. It demands that, okay, if x, that means if the Poisson random variable takes values in either takes 0 or 2 value, g of x give it is defined as 1, and if x is otherwise, it's defined as 0. Okay, now this kind of random variable is called an indicator random variable. So how do you write it in a proper way? You write it like g of x is 1. It's kind of a Bernoulli random variable too. If x belongs to 0 comma 2 and 0 otherwise, right? This is a random variable. But you can see it's kind of an indicator random variable. So, and also it's a Bernoulli. What it means is that it takes 1 with certain probability. With probability what? And it takes 0 with probability what? That's you have to find, right? That essentially you have to find. With probability what? So you can observe that gx takes 1 with probability. When? So essentially gx takes 1, gx takes the value 1 if x is in this, right? So therefore probability gx is equal to 1 is same as probability x belongs to this, and x is a Poisson random variable. So therefore it's nothing but now Poisson random variable ka PMF dekho, because essentially it boils down to the fact that probability of gx is equal to 1 is nothing but probability the Poisson random variable is taking 0 and 2. So what is the PMF of Poisson random variable? So probability x is equal to I, where I is greater than equal to 0, is nothing but lambda to the power I e to the power minus lambda by I factorial, right? This is a PMF. So you have to just find probability x is equal to 0 and probability x is equal to 2 and add them up, right? Because by additive law of probability, this is probability x is equal to 0 plus probability x is equal to 2. I am teaching you everything from the fundamentals, okay? All the ideas, basic ideas used. And now you related both of them to this. So you get lambda is equal to 1. Here it's given mean is equal to 1. So it's nothing but e to the power minus 1 by I factorial. Now here I is equal to 0 and I is equal to 2. 0 factorial is 1 and 2 factorial is 2. So it's nothing but e to the power minus 1 by 1 plus e to the power minus 1 by 2, which is nothing but e to the power minus 1 times 3 by 2, right? So therefore this is this option. Expectation of gx is nothing but what? Expectation of boundary random variable is nothing but p, right? So therefore this is nothing but p, and p is equal to this. All of you got it, guys? Yes or no? Okay, so if it is a continuous random variable, you know that essentially you have to find that if let's say it was a continuous random variable and it was like this, right? So it means that this probability is nothing but probability this. And now you know that it's nothing but 0 to n f of x dx, right? 0 to f of x dx. That's how for continuous random variable the probabilities find out, right?
Okay.
Because for continuous random variable, every continuous random variable, okay, no, this is not actually true. I'm sorry. For what is the definition of I am again, thank you for asking this question, Shuvash. So what is the definition of a continuous random variable? A continuous random variable is a random variable whose CDF is continuous. Understand this very carefully. A random variable whose CDF is continuous is called a continuous random variable. Okay. Nothing in it. So where is this continuous of what? Continuity of what in a continuous random variable? If you say continuous random variable, x is the continuous random variable, then you should ask that what is this continuous thing in a continuous random variable? That continuous thing is nothing but the continuity of the CDF. So continuous random variable is nothing but the continuity of the CDF. And therefore, for a continuous random variable, you can always write this as probability x less than equal to 2 minus probability x less than 0, right? And therefore, this is nothing but f of 2 minus f of 0. Because all continuous random variables do not have PDF, okay? They have a CDF, continuous CDF, but they do not have a PDF. Rather, they do not have a continuous PDF in that sense. And so it will be hard to integrate that, okay? So it will be hard to integrate that if they do not have a continuous PDF. So continuous CDF doesn't always mean you have a continuous PDF. You can always make a PDF to make it continuous, okay? But it will not always be that way. That's something you have to understand, that not all random variables may have a PDF. Okay, so that's why it's important to have it in terms of in CDF format. Okay, so if it has a PDF, then you can do it by integration. So if you want to do it in terms of PDF, it may be hard sometimes because the PDF may not be well behaved.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.